I am Balaji and I am going to present the seminar on the topic of role of sensors and transducers in a ventilator system. On coming to the introduction section, a ventilator is a life-saving medical device that supports or completely replaces a patient's breathing. It delivers a controlled mixture of air and oxygen to the lungs, especially in ICU, anesthesia, and emergency situations. The main feature of a ventilator is continuous real-time monitoring, and this is made possible only because of sensors and transducers. Moving to the working principle, a ventilator works by giving oxygen-rich air during inspiration and allowing the lungs to empty during expiration. A microcontroller inside the ventilator adjusts parameters like pressure, volume, flow rate, and oxygen concentration. Then, why we need sensors and transducers? Sensors and transducers help the ventilator to monitor the patient's breathing continuously, control pressure and flow safely, detect problems like tube leakage, blockage, apnea. Then, what are sensors and transducers? First, what is a sensor? A sensor detects physical quantities such as pressure, flow, temperature, humidity, or oxygen concentration and converts them into electrical signals. Then, a transducer. A transducer converts one form of energy into another. In ventilators, mechanical pressure or flow is converted into electrical signals. This is the comparison between sensor versus transducer. Then, moving to the major sensors used in a ventilator. There are pressure sensors, flow sensors, oxygen sensors, temperature and humidity sensors, and CO2 sensors, that is mean by carbon dioxide sensors. Coming to the pressure sensors ensure that important parameters like PEEP and PIP are maintained safely. They prevent lung damage such as barotrauma. Common types include capacitive sensors, strain gauge sensor. Then coming to the flow sensors. Flow sensors measure both inspiratory and expiratory flow. They help in calculating tidal volume and minute ventilation. They also detect whether the patient is trying to breathe on their own. The types include thermal. Coming to the oxygen sensors ensure the patient receives the correct FiO2. Too little oxygen causes hypoxia. Types include galvanic, paramagnetic, and zirconia sensors. Coming to the temperature and humidity sensors, these sensors are used in the heated humidifier. They keep the inhaled gas at body temperature and 100% humidity, preventing airway dryness and improving comfort. On coming to the carbon dioxide sensors, this is also called capnography sensors. Measure exhaled carbon dioxide. They help detect apnea, airway disconnection, or ineffective ventilation. There are two types, mainstream and side stream. The mainstream includes sensor placed directly in the airway. Side stream includes gas sample taken to a remote analyzer. The common transducers or the pressure transducer, flow transducer, piezoelectric transducer, galvanic transducer. Next, the pressure transducer uses a flexible diaphragm bonded with strain gauges. Applied pressure deforms the diaphragm, changing electrical resistance. The change in resistance is converted to voltage using a Wheatstone bridge. The control system integration. Ventilator control loop. The sensors measures patient and system parameters. Signals goes to the microcontroller and microprocessor. Display shows measured data and alarms. Alarm and safety features. Pressure alarms, it will be high or low airway pressure. Oxygen alarms, low oxygen concentration. Apnea alarms, absence of breathing effort. Power failure, disconnection alarms. Advantages of sensor integration. Accurate and real-time monitoring. Automation reduces operator workload. Enhances diagnostic and therapeutic decisions. Future trends. Smart sensors with built-in signal processing, AI-based adaptive control for automatic adjustment, miniaturization, and self-calibrating. The conclusion, sensors and transducers are the core components of a ventilator system. They ensure accuracy, safety, feedback control, and real-time monitoring. Continuous innovation is improving ventilator performance and patient outcomes. Thank you.